Okay, and this is 10.6, so now we're going to do kites and trapezoids. So kites look like diamonds. That may be what you called them when you were in other grades, but we're going to call them kites. Here's the things about kites. The diagonals are perpendicular, so that's the same. One pair of opposite sides are congruent. One pair of opposite angles are congruent. Okay, so I got to read this carefully. So that means this angle and this angle are equal to each other, but the other two are not. One diagonal is bisected, so this diagonal is bisected, the other one is not. And one diagonal bisects one pair of opposite angles. So we also have these are equal to each other. Okay, but notice that half of the kite basically doesn't match up or isn't congruent. So you have to be kind of careful with kites. All right, let's do an example. So Lucy is framing a kite. So the dowels are going to go right here. This would be the frame of the kite. Would be all those pieces. Okay. She used two dowels that measure 26. Okay, so these are congruent. She used one dowel that measures 48. That's this one right here in the middle. And two dowels that measure 30. So those are also congruent. So we need to find out how long this one is. That's what we're looking for. So I'm thinking we're going to use some triangles here. What do you think? All right, so, I guess the X is supposed to be that whole long KL. So let's talk about, I'll use green. Let's talk about this part because we know that we have 26 on this side and we know that the other one is bisected, which means that this is half of 48, which is 24. So now I can find this side. I'll put an A, I guess, because we're going to use A squared plus B squared equals C squared. So we have A squared plus 24 squared equals 26 squared. Okay, so we're going to subtract. We're going to end up with A squared equals 100. A equals 10. So that means that little short piece of KL is 10. And then we should be able to do the exact same thing with the longer part. So we're going to use this triangle right here. So we still have our 24. So now this is going to be our A, which I should make it the B. Anyway. Okay, so now we're going to have A squared plus B squared equals C squared. So we're going to have A squared plus 24 squared equals 30 squared. And when you work that out, A is equal to 18. So KL is going to be equal to 10 plus 18. So remember when you're doing this, you're always looking for triangles where you know two sides so that you can find a third side or something that's congruent so you know how much both sides are. Okay, so this kite we're going to do angles. So CDF is 52. CAB is 30. BD is 72. So this whole thing right here is going to be 72. And FC, this little one, change colors. This little one's going to be 15. Okay. So if CDF is 52, that means FDA is also 52. And this is 52. Then ABC is going to be 52 plus 52, which is 104. So ABC is 104. BCD is going to be 70. I did that wrong. Back up, back up, back up. That's not the bisected one. Let's start over with this part. Let's start over. Okay, so if this is 30. This is not 30 because, I mean, this is not 52 because I have to have, this is a right angle, so I have 90. So this is B, this is FDA. Let's do this one. Okay. Let's try that one again. Okay, so FDA is going to be 90 plus 30. And then I'm going to subtract that from 180. Okay, so this is 60, which also means this is 60, which means this is 52. So B, C, D, I'm going to change colors again, maybe. Okay, so B, C, D is this part. And we know that we have a isosceles triangle with 52 and 52. So now we're looking at this triangle right here. So we have 52 plus 52 is 104. And 180 minus 104 equals 76. Okay, and then I have to redo this one. See, now you see how teachers do stuff. Isn't this enlightening? ABC is these two together. So ABC is 60 plus 52 equals 112. Okay. FB, so DB is 72, so this is going to be 72 divided by 2, which is 36. And then BC is going to be A squared plus B squared equals C squared. So I know this is 15, and I know this is 36. So I'm going to have 15 squared. So I'm going to have A squared. No, I'm not. I'm going to have 15 squared plus 36 squared equals C squared, because that's my hypotenuse. And that is going to make C equal to 39. So try the math and make sure it works out. Okay. Trapezoids. Okay, so there's two different kinds of trapezoids. A plain old trapezoid, the bases are parallel. Remember these little arrows we made to show parallel? Okay, two of them are parallel. And each lower base angle is supplementary to the upper base angle on the same side. So they're consecutive, right? These two make 180, and these two are 180. When you have an isosceles, both pairs of angles are congruent. So this is equal to this, and this is equal to this. These lines are parallel still. Diagonals are congruent. So that means that if I draw this and this, those lines are equal to each other. So if it has one pair of congruent base angles, then it's isosceles. So you know if these are the same, then it's isosceles. Okay, so here's the angles in a trapezoid. So we have A, B, C, D. And what did we just say about those two angles? A and D is going to be, actually, any pair of complementary angles, consecutive angles, is going to be 180. So we have 180 minus 117. Okay, so that's going to be 63. Example number 4, this is 21.9. This whole thing is 32.7. And remember what we said, the diagonals are congruent. So that means J is 32.7. And if I subtract subtract MB, because that means FM is also 32.7. So if I subtract MB, then what I have left should be FB, which is 9 from 17 is 8, 0, 1. 10.8. So FB is 10.8, which means, no, I said that wrong. Did I say that right? Yeah, FB is 10.8. Altogether, it's 32.7, which means that JB should also be 10.8. Because it's congruent, those should be equal to each other. Okay, so we want this one to be isosceles. So if AC is 12x minus 11, and BD is 9x minus 2, if we want it to be isosceles, that means those are equal to each other. So if we want an isosceles trapezoid X has to solve this. So I'll use my algebra. And X is equal to 3. All right, 2 more. Okay, isosceles trapezoid again. The measure of angle E is twice F. So if this is X, this is 2X. And I'm looking for H. So let's go back up here and look. Isosceles trapezoid. The base angles are congruent. So that means that this is also X and this is also 2X. So I have 1, 2, 3, 4, 5, 6X, and that has to add up to 360. Divide by 6, and I end up with X equals 60. So that means my small angles are going to be 60, and my larger angle is going to be 120 because it's twice as much. So the measure of angle H equals 120. Okay, so now it looks like I have 2 trapezoids. A big one and 2 little ones. So I'm looking for this. HI, this one is X plus 1. LM is 2X minus 4. And KJ is 2X plus 1. Okay, since LM is in the middle, it's half of the 2 bases. So here's what it looks like. LM is equal to 1/2 HI plus KJ. All right, so that means I have 2X minus 4 equals 1/2 X plus 1 plus 2X plus 1. So let's combine all those terms. I have 3X plus 2. Okay, so to get rid of my 1/2, I'm going to change colors first. To get rid of my 1/2, so as much room as I get, I'm going to multiply this side by 2 and this side by 2. Because what that does is these guys cancel out. And I'm left with 4X minus 8 equals 3X plus 2. Minus 3X. So I have negative 8X minus 8 equals 2. I'm going to add 8 to both sides. X equals 10. And then I'm looking for LM, which is going to be 2 times 10 minus 4, which is equal to 20 minus 4, which is 16. So this was the real answer that we were looking for. All right, we are pretty much through the Unit 10 notes, and we have 10.7 to go, which is a kind of a whole different thing to get you ready for 3D figures, and then we will do test review.